All right, so can we begin again to determine dx and dy? What I would prefer to do, instead of writing a lot of things on the board, to talk through it, okay? So, what is the distance, Vx? What two things is that dependent upon? Constant what? Constant velocity, excellent. Remember, the Vx, we're ignoring air friction, of course. We're working in a perfect setting. But if it were a perfect setting, the Vx would be constant, completely constant. There wouldn't be any interference with friction. Next unit, Newton's laws, will talk about motion with friction. Since September, we've been talking about motion without friction. Now we're going to start to talk about motion with friction when we do the next unit. It's going to be a very long unit. We're going to do all of Newton's laws, correct? Now, so Vx is constant, doesn't change. And what else is it dependent upon? The time, correct?
Yeah.
So this is going to be equal to the product of Vx and T1. What is Vx and T1?
43,000.
What is it?
The final answer is 43,000.
No, just for dx1, not for both.
Yeah, for dx1 it's 43,500.
43,500.
Yeah.
Is that correct? Meters. Yes?
Yes.
So this is 43,000. Just now guesstimate. Guesstimate. What is this going to be, do you think?
Same.
It's not going to be the same. It's going to be actually what?
Velocity.
It's going to be a little more, correct? Because you have this area. This was the perfect parabola. So this area here would be 43,000, correct? This distance. So you can see that it's going to be a little more. So if you get a number, if you're guesstimating and you're trying to keep track as to whether or not your answer is correct, when you get the next part, which is Vx2, and it shouldn't be less than, and it shouldn't be double it. It should be something greater, but not terribly greater. Yes? So what is dx2 dependent upon? What is it dependent upon? The time it takes to do what? The distance here is dependent upon what time? We didn't do it yet. What time is it dependent upon?
T2.
T2. So what do we have to solve for before we do dx2? We have to solve for T2. Now, isn't that going to fall from a height? Correct? Right? What is that height, what is that value therefore going to be dependent upon? dy total. Correct? What's the shortened version for time in free fall? Think. I'm going to erase all of this. Okay? So we have room to work. Correct? Is that okay? What is it dependent upon? Yeah. Remember we actually wrote a shortened equation if you have free fall where the initial velocity is 0. Didn't we say dy, the distance in free fall, in this case it's d total, equals v naught t, correct? In this case it's going to be, we don't know, right? We don't know what it's going to be, right? It's going to be t2, right? Correct? And then this is ty total, right? And then you're going to say plus 1/2 g t2 squared. Isn't that what you're going to say? Right? Remember, it comes from the equation dy equals v naught t plus 1/2 gt squared. Remember? So v naught is 0 because it's falling from 0. T2 is the t. G is 10, 1/2 of 10 is 5. So this term drops out. dy total equals 5 t2 squared. Isn't that correct?
Yes.
Are you sure? Okay. Are you otherwise preoccupied there, Professor? You doing all right? Okay, you want to put the phone away? Excellent, excellent, excellent. Okay. So T2 is going to equal what? dy total
divided by 5.
dy total divided by 5. Yes? You see that? All right. So let me erase this then. That's where that formula comes from. Right? So we say we're looking for T2, correct? We're looking for T2. So we say that it's going to equal dy total divided by 5. Isn't that correct? Yes or no? Yes? What is dy total? 38,845. So, what is the square root of 38,845 divided by 5?
88.
So T2 equals,
88.1.
so we'll say 88, correct? So do you see that the distance to go this is based upon T1, which is 87, and then this is based upon T2, which is 88. So do you see how you get that little bit of extra? So when you're doing this, dx2 should be, in type 3, should be a little extra. Okay? What angle would make it larger? What angle? What would the angle of firing would make the distance traveled the farthest? What angle?
Still 45.
Okay, you haven't, what is it, 45? Excellent. I'm impressed. You've been doing your reading. Excellent. 45 degrees would make this maximum, correct? Okay. So, also a little height would do that too, but if the height's constant, 45 degrees. So, what is the square root of 38,845 divided by 5? It's 87, correct? Did we write that down?
88.
88, sorry, we didn't write that down. T2 equals 88 seconds. Okay, so what is dx? What's the equation for dx? Isn't it Vx, which is still the same, doesn't change? The Vx is here, 500 meters per second, times 88. The time it takes to go from here to here is 88. Okay, so this is dx1, this is dx2, correct? So what is 500 times 88?
44,000.
What is it?
44,000.
44,000 even?
Yeah.
It's dx2. dx1 equals 43,500. So the answer is going to be dx total, which is the more important value. You want to know how far it went, correct? Is going to be what?
87,500
87,500
meters.
All right, let's do something. How many kilometers is that? 88,000, right? I'm sorry, 88 kilometers divided by 1,000, correct? Right, so it's 87 kilometers. That's pretty far. 87 kilometers. What is it in miles for our American brethren? What is it in miles? So you would do what? 1,600 meters per mile, correct? So what is 87,500 divided by 1,600 meters? Come on, guys, you can do this. I have one person working.
54.
Is it 54? Do you get that? Does everybody get it? Jacob, I want you to do that.
54.
87,500 divided by 16. We always verify answers. So we got one verification. Is that correct, Amir?
54.6.
54.6, so 55? 55 miles? Is that what you get, Jacob? So the total distance equals 57?
Yeah, I get that.
57 miles.
About that.
Jacob's from Germany, they don't use miles, they're very confused.
No, we don't. No.
Yeah, Amir is from the UAE, he's a little bit confused too, but he got the right answer. Excellent. Excellent. How many Americans here? We have one, sort of two. Yeah, you're American, right? Yeah, yeah. Right. And I'm from, what is it?
It's 55.
How come it's 55? Is it
We all
50?
got 55. different.
54.6.
Yeah, he's asleep. We all got 54.6.
Stop
That's
sleeping.
you put in the wrong number.
No, I don't need.
We're having a debate here in terms of whether or not the
Wait,
answer is
I'll go
correct.
again.
Okay.
No one cares.
Yeah, we got 55.
55.
Can't remember the answer.
Okay, so 55 miles. So it's very far. Okay. During World War I, the Germans were attacking through Belgium, and they swept into France. And they were stopped, heroically they were stopped, short of Paris. And what happened, they were close enough to Paris to bomb it with cannons. And the cannons were not elevated even that high. And they were able to hit Paris because they were well within the distance for a projectile to travel from where they fired to Paris. So history is full of examples of projectile motion. Who was one of the first persons to study this kind of motion, ballistic motion?